Let me know when it's time there, Martin.
Yeah, 1 minute.
D1S3. Am I beautiful?
Handsome.
Excellent.
Smash it.
Okay. We're all here, yeah.
Ready? All right then. Hi everyone. You all know me. I'm Alex Taylor. So this is the first of my 2 presentations this year, which are REXX themed. So it occurred to me that over the years, I've written a bunch of REXX libraries, but I suspect a lot of people don't really necessarily know about them, because I usually just write them because I need something done, and then I sort of throw them up on the NetLab site or something, and not necessarily doing a great job of marketing them. So what is with these REXX libraries? Well, the more I use REXX, the more, well, I often find myself thinking, darn it, I wish there was a way to do this in REXX. And sometimes there is, if I research a bit, and sometimes well, there isn't, so my solution is to just write a REXX library that does it, whatever it is. So as a result of this, I've written several REXX libraries over the years, probably about 5 or 6 in total. A couple of them are pretty esoteric and aren't going to be covered by this presentation. But the more interesting ones are available on the NetLab's Subversion site. The URL is on the slide if you can read it, but it's the REXLibs project on NetLab's track. And the source code is there, and I always try to make sure the latest source code is there along with the latest releases, which are downloadable from the site as well. There is one exception. Actually, 4 of the libraries that I'm talking about today are under the REXLibs project. There is a 5th one, which I will cover right at the end briefly, which is also on NetLabs, but under a different project. And I'll address that when I get to it. So, let's dive into the first one, RxLVM. This is, as you might guess, the REXX interface to LVM, which is the Logical Volume Manager. This was, I think, my first REXX library. I think, hence the question mark beside it. Pretty sure it was the first one I wrote. And this was probably almost 20 years ago that I wrote it. Because I wrote it when we were working on eComStation, one of the 1.0, 1.1, that kind of generation of releases. And we had realized that the IBM Logical Volume Manager interface was terrible, and we were looking at coming up with ways to maybe make it more accessible. One of the ideas I had, because I was working on eComStation at the time, which was managed by Tin Chung, who is a really big REXX guy. And he loved to do as much in REXX as possible. So I came up with the idea, well, I could write a REXX wrapper to the LVM API, because the LVM API is documented, it's available to use. That's how we wrote the installation volume manager and a few other things. But we never really ended up using that idea, but I still wrote the library because it was useful for certain things. But the one decision I made when I was writing this library is, accessing the Logical Volume Manager and doing stuff in the Logical Volume Manager. This is your disks partitioning management system. So it's very easy to do very bad things. Erase partitions or erase your disk or do something. And for a REXX API, which is, much more accessible and easy to use, I thought maybe it might be putting a little too much power in people's hands to make it able to make changes. So I made the design decision early on that this would be read-only, You can query information out of LVM using it. You cannot make changes. The only exception, if it counts as an exception, is that you can tell the LVM engine to refresh removable media, because that's not a destructive operation generally. So what can you do with REXX LVM? Well, you can open and close the LVM engine. And that's a concept that you kind of have to understand when you're using LVM. Every time you start using functions to manage your partitions, you have to get basically what amounts to an exclusive lock on the LVM system, the volume management system. And the terminology that it uses is called opening and closing the LVM engine. So there's a function that opens the LVM engine. Then the idea is you make all your changes or do whatever you're doing, query for the information that you're trying to get. Then when you're done, if you've made changes, you call a function to commit your changes, and then you close the LVM engine. While the LVM engine is open by one program, nothing else can open it. So this is why, for example, if you have LVM open in one window and you try to run DFC or something in another window, it'll give you an error message, something like cannot access hard disk, or cannot cannot open LVM engine, cannot get disk access handle, something like that. And that's why, because only one program can have the LVM engine open at the same time. This library is no exception. If you have the LVM engine open in a REXX script, you can't do anything else with LVM in another program. Even though this API, this REXX API is read-only, it still has to obtain that exclusive lock because it can't do anything with the LVM engine, even query information out of it, without opening the engine and therefore getting the lock. So something to keep in mind if you ever do want to use this library. But there are some useful things that you can do with it. So besides opening and closing the engine, if you have the old IBM Boot Manager installed, you can actually access it. You can get information about Boot Manager menu, the volumes and partitions that are on the menu. In principle, if I allowed it, you'd be able to add and remove partitions from the Boot Manager menu, but that counts as not read-only, so I haven't permitted that, even though there's probably not a high risk in it. More commonly useful, you can just get physical information about your disk drives. You can get logical information about your volumes. You can get information about partitions. And if you're familiar with how LVM works, these are kind of the different layers of logic that it uses to map your disks to the operating system. I am possibly skimming over some of that, so I do assume that most of you know what the logical volume management engine is. It's basically it's the low-level layer of the operating system that does partition management and volume management. So it would have replaced what was fdisk and so on in older versions of the operating system. But yeah, that's basically what you can do with the library. Because it works with LVM, which was introduced in Warp Server for eBusiness, which is OS 2 4.5, you have to have at least that version of OS 2 to be able to use it. It simply will not work. If you try to use it on another version, on an older version of OS 2, you will probably just get a pop-up log entry saying this API cannot be found, I would guess. I haven't tried it. As I kind of touched on, it does require understanding certain LVM concepts, like how to open and close the LVM engine, how to use handles. So any operation that you do on the LVM engine, you basically, if you want to do an operation on an object, every object is represented by a handle. So a disk drive has a handle, a volume has a handle, a partition has a handle. So you need to get the handle to do anything with that object. And I will show you a brief, very simple, actually hold on, I will show you the script first. So here's an example of a very simple REXX LVM script. So what does this script do? Well, it registers the library. So if you're familiar with REXX, you know this syntax here. REXX LVM is the name of the DLL. It asks for the entry point REXX LVM load funcs, registers it under the name REXX LVM load funcs, and then calls REXX LVM load funcs. So that gets you access to the LVM API. So then, if you want to actually do anything with it, first thing you got to do, open the LVM engine. That's, as you might guess, what that does. Now, generally speaking, all of my REXX libraries the functions that actually have a meaningful result will return something, usually a return code. In the case of the LVM, RX LVM, this was the first REXX library that I wrote, so I didn't quite have the same pattern for my return values as I adopted later. Basically, it will return either a meaningful result based on the operation you're doing. So in the case of RX LVM engine open, I think it just returns 0 on success. If an error occurs, it will return a string that starts with error colon, and that will be followed by a return code, which is probably going to be the return code that was generated by the actual LVM engine itself. So you can, you see the logic here, it checks for the error prefix, and if it finds it, it parses out past the error prefix and then finds the return code, and then in this case, it just prints it out and returns it to the calling shell. So now that we've done all the preamble, we can actually do stuff. And the only thing we're really doing here is call RX LVM get volumes, which you would probably guess gets you a list of all the volumes that you have in your system. And then it just does a for loop, or a do loop, as we say in REXX, and prints some basic information about each volume. And that's it. You probably notice, or if you're paying attention, that the script actually ends here before I call LVM engine close, and that's because it will automatically close the LVM engine when the process ends that's using it. So I probably should, if this was a real script, put in RX LVM engine close at the end just to be tidy, but there wasn't that much space on the slide, so I decided to just kind of make it as simple as possible.
And that's nothing to do with the REXX implementation that you did, it's just...
Yeah, it seems to work that way. Once the process that's got the LVM engine open terminates, it seems to be smart enough to close the engine itself. Now, this is a bit, where can I find my tool? There we go. Okay. So the script that I have written is test lvm.cmd. This is the exact script that I just showed you on the slide. So this is what the output will look like on this particular virtual system. So it found 8 volumes. It's showing you the requested drive letter of each volume on the far left. And then after the arrow, the actual drive letter that it has. You may notice some of them have a star beside them. That means it has no preferred drive letter. So it'll just take the next one that's available. And specifically, drive C, E, and G are hard drive volumes. They're all JFS. You can see that's the type, HDD. The flags here, I would actually have to look up. I have to remember what a couple of these columns mean. I just kind of dumped them into the output to show you. But the volume name as seen by the engine is the one on the end. And you can see these two are CD drives. They have nothing in them. CD drives CD, DVD, Blu-ray drives, they will all show up as having 527 megs of space, just because that's the way IBM wrote it. And then these ones are, these two are VirtualBox shared folders, VBox SF. And that one is my NetDrive virtual drive for attaching LAN drives. So if you see, yeah, I've got some LAN stuff on Drive X, so that's why Drive X is showing up there. It's a very simple example of RX LVM. Like I said, you can't make any changes with it, so possibly it's not as useful as some people might like, but you can still get useful information out of it. Sometimes I do find it handy to just figure out if I'm in a program, I'm in a script, I need to know what volumes are available to an extent that the sysdrive map function from REXX util can't really tell me accurately. And I can see what type of device they are as well, whether they're hard drives, CD drives, removable drives, etc. So, kind of handy.
And you use no handles in this, it's only when you get one level lower that you need handles, like for opening one of the volumes or.
Hang on a second. Let me bring back the slides here, and oops. So RxLVM get volumes actually returns a stem variable, where each item in the stem is the handle of a volume. So volumes.I in this loop is the handle of that volume.
So the handles are numeric?
No, well, I mean, technically they're like hex values or something. They are internally implemented as 32-bit integer values, but doesn't really matter what they are in REXX, because REXX just sees everything as a string anyway.
So that's your REXX implementation inside
Yeah.
of that function.
Yeah, actually, you know what? I will show you. I decided to not print the handles of each one just because. One second, actually. I have to back up for a moment because I misspoke a moment ago. The stem variable, I'm sorry, does not return the handles. It returns a list of fields where the first field is the handle. The second field is the preferred drive letter. The third field is the current drive letter, and then there's a whole bunch of others. So sorry for misspeaking there, but when I was writing this sample, I figured people probably wouldn't be that interested in seeing the handles, but let's show you, and if I can figure out where. There we go. Sorry, working with two monitors when I can't directly see one of them is a little challenging sometimes. Okay, so yeah, editing a script is going to be more fun.
Yeah.
So I will, rather than parse that out, I will actually just show you what the raw return of each item in the stem is. So just say volumes dot I. And these are just space separated fields. That is an I and not a 1, right? Yeah.
Yeah.
Yeah, so that's the raw data output. And the first field is the handle. So they're just internally, as I said, 32-bit integers. The REXX LVM library just converts them to hex strings and returns them like that. Because, like I said, everything is a string to REXX, so simpler to do it that way.
Okay.
And there is full documentation with this, by the way. It's downloadable off NetLab's track on the site that I indicated on the slide. The one second. There is way too. Seem to be missing a bunch of. Okay, here we are. Information from, but it comes with full documentation. In this case, it's this one. So it just gives you a brief overview of what it is, how to use it. So how to load the library, how to open and close the LVM engine, how to use handles, how to parse the error strings, and then these are all the actual functions. So RxLVM get volumes, so it returns a list of all volumes, and then this is the format of the actual stem. So it's handle, letter, which is the actual letter, then the preferred letter. I think I might have got that backwards when I was describing it a second ago. Then the file system name, the size of the device type, whether or not it is bootable, and then the actual name of the volume. So you can see the recognized device types are hard disk, removable media, CD, including DVD or Blu-ray, LAN drive, and unknown. And then,
What about like Linux volumes and stuff? What happens? It shows the type.
Well, okay. It depends on whether or not you have them actually defined as volumes, because they may just be partitions. If you haven't added them as volumes in the volume monitor, in the logical volume manager, LVM will just see them as partitions, not volumes. So you would see them if you used the get partitions.
Okay.
And they would probably show up as, well, there has the OS flag, or the partition type, and then that's a 2-digit hexadecimal value. So I think 8.2 is Linux, and 8.3 is Linux swap. Yeah.
And just, this isn't specific to this, but in order to make them volumes, can you just assign a letter and it'll do it?
Well, under the hood, it's a little more complicated than that, but in the user interface, basically, yes. Assigning it a volume letter will make it a volume.
And the LVM.
Can you assign a volume letter to a file system that's not recognized by the operating system? No.
Yeah, I think so.
Can you really?
You might not be able to assign one to.
Like a Linux swap volume?
No, hold on. Yeah, you should be able to, because the LVM does not operate on a file system level. It doesn't care what the file system is.
I guess.
Actually, I have a swap partition on here.
When you plug in a thumb drive, that if LVM doesn't give it a drive letter, that's it. In other words, when you plug in a partitioned thumb drive that has no LVM on it, LVM assigns a drive, that's true, an LVM doesn't assign the drive letter, the operating system assigns the drive letter.
Well-
So take a thumb drive, right, a small one,
Mhm.
that's partitioned,
Yeah,
that has no LVM on it, and
Yeah.
you plug it in.
yeah. LVM will see that it has no preferred drive letter, and it will give it a drive letter. Probably the next
Even
one
if there's
available.
no LVM, even if the DLAT hasn't been initialized?
Remember, LVM doesn't just handle volumes. It handles everything from the raw disk up to the volume level. So it handles disks, it handles partitions, it handles.
Yeah, okay.
I
So.
just did it, I assigned an S to the swap partition on here.
Did you really?
Yeah. Now I have to reboot to find out if it actually works, but it didn't show.
It'll always be S, but it'll never be readable.
Yeah, well, it just rebooted.
Okay, anyway,
Let's move on.
Yeah.
I don't want to spend too much time on any one
this
library.
isn't the LVM session, this is the
That's right.
library.
Okay, so next one is RxULS, which is the REXX Unicode library. This, in my opinion, is possibly the most interesting to me of all of them, and potentially useful, depending. So ULS, or Universal Language Support, is the name given to the OS/2 Unicode support subsystem, the Unicode API, basically. So RxULS tries to simplify access to the ULS API. That said, simplified it may be, but it does still require some understanding of Unicode and ULS concepts. Getting to the meat of it, though, what does RxULS do for you? It includes various functions to do various things, including converting text between different code pages, which can be very, very handy, especially when you're pulling information from other platforms or off the internet, and you're not dealing with basic ASCII. So how many times have we found a text file that originated on Windows where all of the accents and stuff are mixed up? Or UTF-8 even, where trying to read it can be a challenge. Besides code pages, it can also convert text to and from different Unicode formats, because there are different Unicode formats. Unicode is a huge standard, and it includes a number of different formats for encoding text, which are not necessarily compatible with each other. So the two main ones that ULS and thus RxULS supports are UCS2, which is approximately what is now called UTF-16, and there's UTF-8, which is probably the most famous one. UCS2 or UTF-16 is mainly used for internal data manipulation, like by APIs and so on, whereas UTF-8 is most commonly used for actually transmitting data, sharing files, that kind of stuff. So if you come across a Unicode encoded file, or a file that alleges to be Unicode encoded on the internet or from somewhere else, it is almost certainly UTF-8. But that's not all. We can also transform text. So, what does transform text mean? I'll show you in a little bit, because it's an interesting topic. The next thing that it can do is a little more esoteric, and that is getting information about a locale. Now, ULS has this concept of locales, which many internationalization APIs have. So a locale essentially is a set of definitions tied to a particular locale, region, a geographic or cultural area, with common conventions for that area. And the probably most commonly known ones are number format, date format, currency symbol, that sort of thing. If you've ever used OS2 in different environments, or you probably noticed that in some places dates are written in one format, they're written in another format somewhere else.
Directionality is another one, maybe? You know, error.
That can be part of it. That's part of querying text attributes, which I don't get into that much. Directionality is one of the text attributes that you can query. I have never really done that much with that aspect of it because it's very complicated to manage in a useful way. Because when you're dealing with directionality, you're usually trying to actually render text and render it in multiple directions. And that's not something that, honestly, this library is really optimal for. It's good for querying information about text, which is kind of, I guess you could call directionality a kind of metadata about the text, like most attributes. But yeah, you can get information about it. That is part of the information that's in it. But that is more of a text attribute rather than a locale attribute, I would say. There are some useful functions to reformat time and date strings according to the locale, as well as a few other things along that line. And finally, this is one that wasn't actually part of the native ULS API directly, but was so useful I decided to add it anyway. And that's the ability to read and write Unicode clipboard text from a REXX script. So Mozilla, a lot of the Qt apps, like by Mozilla I mean Thunderbird, Firefox, SeaMonkey, anything that uses that platform. They can copy text as Unicode into the clipboard, and it's identified in the OS2 clipboard under a specific format. And then any application that recognizes that format can then add to it or retrieve it or change it. So can a REXX script that is using RxULS, and there are functions for that. So, a brief talk about some important RxULS concepts, which as I said, are kind of necessary. So, first thing you really need to know is what code pages are relevant to what you're doing. OS2 is based still on code pages. The default code page for US English, and indeed most English versions of ArcaOS nowadays, is 850. It used to be 437. Some people probably still do use 437. For other languages, there are other commonly used code pages. Actually, 850 is used not just for English, it's also used for most Western European languages. French, German, I think Spanish, a few others, Catalan maybe. But there are other code pages that you need for other languages. So for Cyrillic, for example, you'd want code page 866. For Greek, you'd need, I think it's 859 or something. For double byte character sets, there's a whole other set of code pages for those. Japanese is 949, Korean is 950, Taiwanese is Taiwanese is 950, Korean is 949, and Japanese is 943. But yeah, as you can probably tell, I've had to deal with a lot of these, so I do remember some of them. Anyway, the documentation that comes with RxULS does include a list of all the most important code pages for dealing with text encodings. Now, when you're dealing with Unicode specifically, as I said, there are a couple of different Unicode encodings. UCS2 is the big one. This has been repackaged by the Unicode Consortium as UTF-16. Strictly speaking, UCS2 is a subset of UTF-16, but it's the one that most people are going to be using anyway, so for our purposes, it doesn't make much difference. That is actually assigned a code page number that you can use to refer to it, and that's code page 1200. And then UTF-8 can be accessed under the name code page 1208. There's another special IBM OS2 unique Unicode code page, which I didn't list here, which is 1207. That's a special internal code page that's used if you want, it's supposed to be used, I think, if you want to render Unicode text in Presentation Manager. Realistically speaking, you're not likely to need it that much because most of the Presentation Manager controls were never updated to use Unicode anyway. If you want to render Unicode graphically, you have to do it directly through GPI functions, which is the low-level graphics API, and it works perfectly well. But if you're using that, you can actually use code page 1200 directly. And the benefit of using code page 1200 is that all of the ULS functions use UCS2, that is to say, code page 1200 strings internally. So to do anything with a ULS function within the actual API, not using RxULS, but if you had to write a C program or a C++ program or something that used them, to use one of the to use one of the ULS functions, you'd have to first convert your string into UCS2 format. RxULS takes care of that detail for you, generally. A lot of the functions also take a number of kind of common parameters. So I've listed them here. I'm not going to try and explain them because they are quite complicated, quite difficult to understand. Even I find them confusing. Even I usually have to look up what they do every time I try to use them. A couple of them you may find yourself needing to use from time to time. The one that you're probably most likely to use if you ever find yourself using RxULS is the substitution character. And that is, if I'm converting text to a code page, and that code page does not have a value, like a code point, for this particular character, what do I do with it? And the answer is it replaces it with a substitution character. And you can define what the substitution character will be. The default is like ASCII 128, which is the house symbol. But some people like to change it to a question mark or something like that. And the others, like I said, the documentation does, I hope, a reasonably decent job at describing them. Certainly better than IBM's documentation did, which required a lot of reading and rereading and experimenting to make sense of. But yeah, as it says, these can be confusing, so read the documentation. Now, I have two RxULS examples, because I can't really cover everything that it does in what will fit on one slide. So the first example is very simple. It takes a string with a couple of accented characters in it, a café in Trois-Rivières, and if anybody who doesn't know, Trois-Rivières is a medium-sized city in Quebec, which you will probably drive through if you ever have to go from Montreal to Quebec City, or visit the Mont Saint-Anne ski resort, which is a great ski resort for anyone who wants to go skiing. I digress. So what this example does is it basically just converts this string from code page 850, re-encodes it as code page 862, and it specifies a custom substitution character of ASCII 3F, which, if anybody is good enough at ASCII to remember what that is off the top of their head, that is the question mark. And then it checks for an error, and then it will just output the result. Then the second thing it does is it transforms the string into uppercase. And this is a little special, because REXX has a function that can translate strings to uppercase, translate. what you may have noticed if you've ever dealt with non-ASCII text is it can only translate basic ASCII Roman letters to uppercase. It can't handle accented characters. This function can. ULS transform. This is what I call a text transformation, which I mentioned on the previous slide. There are a bunch of different transformations which are defined by the ULS API, which you can perform on strings. And one of those transformations is called upper, which means convert to uppercase. And it will intelligently substitute the uppercase versions of accented characters if they exist in the code page that you are using.
And the 850 is necessary to inform that what code page the string is in?
Yes.
Is that why it's there? Okay.
Yes, that is correct. Well done. Because yes, it has no way of knowing what encoding a string is in when you give it, when you feed it in, so you have to tell it.
And what happens in a text window when you display this stuff?
I'll show you.
Okay.
All right, so let's start with, this is the script I showed. So this is what it does. It shows the input string. The resolution on the projector isn't that great, so I don't know if you can see this very clearly, but what we have here is the input string with the original accents here in code page 850, and then it converts the code page 862, which I don't actually remember what that is. I think I just chose it as something that doesn't happen to include accented characters, or accented lowercase e's. So you can see, if you squint, that it has replaced both accented characters with question marks. And then the final line, it has translated the entire string, including the accented characters, into uppercase.
And that's the translation of the original line? Is that right?
That's the translation of the original line. It is translated into uppercase, and it has returned the result back in the same code page, 850. I wonder if I can enlarge that a bit for you. Is that any better?
Yeah, a little bit, yeah, I can
Yeah.
make it out.
Almost.
I thought there were a couple of larger options here. No, that's about it. All right. But yeah. Now, if, for example, I were to use the REXX translate function, which is the built-in function, so say translate you'll notice that it has translated the string into uppercase except for the accented characters, which it has left unchanged because it doesn't know how to deal with them. So that's one way that, see, there's the, so that's the default REXX translate function. Kind of messed it up, as you can see. So the RxULS ULS transform function does a good job of it. So that's one advantage of this library. You can do stuff like that. There is another thing that I'd like to show you, and this is a slightly more sophisticated example. So I didn't put this on a slide because it's kind of long, but I want to illustrate something else that's neat that transformations can do. What if I wanted to take this string, this one is the train from Trois-Rivières to Montreal. Again, it has two accents in it, the same two as a matter of fact, just in a different order. What if I want to remove the accents? Keep the string the same, but just strip off the accents. You can do that. How do you do that? Well, a combination of two different operations. ULS has an operation, a transformation called decompose, which converts accented characters into a base character and a combining character, what's sometimes called a non-spacing diacritic, if that means anything to you. So Unicode has this concept of characters which are just accents, that they take up no space by themselves, but if you combine them with a base character, like an E, it is supposed to draw an accented E. So ideally, using the Unicode philosophy, all accented characters should really be represented as a base character and a diacritic character, an accent character, not as a pre-baked character with an accent. Now, life has not worked that way. Reality has not panned out that way, so we still have a lot of these characters, and we will always have a lot of these pre-baked accented characters, but you can convert them into those combined forms. So that's what this decompose transformation does. It takes it takes the string, finds those two accented characters. One is accent acute, E with an acute, one is E with a grave accent. So it transforms them into just a plain lowercase e followed by the corresponding accent character. Now, that wouldn't display meaningfully under any OS2 code page because most code pages, ASCII certainly, and pretty well any other code page, doesn't have a concept of these combined accent characters for the most part. So when you convert it back into code page 850 for display, those separate accent characters would just get replaced by substitution marks because the ULS API would say, this character does not exist in your code page, I'm sorry, I can't do anything with it. But the value is still going to be there in the original string if you kept it in Unicode format. So what this script does is it converts the input string into Unicode, decomposes the accented characters using the decompose transformation, and then it just loops through the string and looks for any character which has the attribute non-spacing diacritic, which is what it calls those accented characters, and it just skips over them. So your string will have the accents stripped out. Now this is kind of a culturally insensitive thing to do, but sometimes you may need to do something like this for compatibility. So I'll show you.
Rude as it might be.
Yes. So it might help if I.
Other market owners will absolutely love this.
So here are the 3 steps. This is the input string. It's got the 2 accents. Here's the interim step where we've done the decompose. So just for display, what I did was I converted the Unicode decomposed string to 850. So as you can see, it's now got the E's are followed by an unknown character, which is the accent, which doesn't exist in code page 850, so it can't display them. But then I just did that iterative loop where I skipped over the decomposed accent characters and removed them. So now we have the same string except all the accents are gone.
Nice.
What about like with an umlaut, like in
Oh yeah,
English?
works with those too.
But there's a way in English to represent U umlaut with 2 characters, like UE or E.
That's more of a spelling issue than a meaning. Like it's not a semantic thing really; it's a spelling convention. So that wouldn't really belong in this kind of thing. But you could do that. You have to use separate logic basically to like a lookup table or something. But yeah. So anyway, that's one of the slightly more esoteric things that you can do with RxULS. I just thought it was kind of neat, so I provided an extra example for that. If I can find my mouse again, I'll get back to my presentation.
By the way, Alex, 862 is Hebrew.
I thought it was somewhere in that range. Couldn't remember if it was Thai or Hebrew, but yeah.
Hebrew.
Yeah, I think Thai is 872. Isn't it?
They're so close.
Yeah. They look the same, right?
It's all Greek to me.
It's all Greek.
859, I'm pretty sure. No, Greek might be 863.
Oh, there you
I
go.
don't know. Anyway,
If you try to do this conversion the right term on like a Hebrew letter into whatever the 850 or
you'd get a substitution mark because
You get
they
a
don't
question
exist.
mark.
Yeah,
Yeah, okay.
they don't exist under the Latin 1 character set, which is what 850 is.
By the way, what happens when you do that conversion and you have a font that's missing those glyphs?
Well, I mean, the output is just a text value. It doesn't care what font is. It might not even be being displayed. You might be writing it to a file or something. I mean, that say command, like printing it out on screen.
Yeah.
I mean,
Would you still end up with the little houses?
it depends on the rendering environment. In most graphical applications, I think it would get replaced by not a code page substitution glyph, but whatever the substitution glyph in the current font is. And that is usually an empty box.
Right.
Unless you are converting into Unicode and displaying in Unicode, because Unicode has its own standard substitution glyph, which is a diamond with a color inverted question mark in it.
That's what that.
Yeah.
Lovely.
Yeah.
And I had another question, which is, sorry.
Happens to the best of us.
No, the oldest of
Just wait till my meds wear off. I'll be the same. A couple hours. Anyway.
Oh, I'm sorry. In the command prompt in OS2,
Yeah.
is it only able to display like a single byte European character set, or what goes on in there?
So, Lewis knows why I'm chuckling. Yeah.
There's
The short answer is it can display any single byte character set if it can display any character in the current code page that the operating system is set to, which normally is going to be a single byte character set. There are double byte character set versions of OS2 which can display double byte characters in a command prompt. It uses like a special shell add-on called VOShield, which is some module that's part of VBCS versions of OS2, in combination with, I think, some hooks in the video driver. It's complicated, and I only tenuously understand how all the pieces fit together. But either way, you are going to be limited to whatever the current process code page is. So if you see, you probably are familiar with this command. Oops. Did I? Oh, it's CHCP, isn't it? Sorry. Yeah. So this says that the current code page is 850, and I have configured my system to be able to use either code page 850 or code page 932 as a process code page, which is, I don't want to get into the technical definition of that, but basically these two code pages are what command prompts can display. But it can only display one at a time, so if I want to be able to display my secondary code page, I would actually have to switch to it. And that's not something I really want to do in a command prompt, because code page 932 is Japanese, and trying to display Japanese text in a command prompt on a non-DBCS system is, I won't say it's going to be a disaster, but it probably won't produce any useful results.
That's that thing in the config sys where it has two codes.
Yeah, that's set code page command in config does this, and there's a maximum of 2. Doug, you had a question?
Don't you have to have a special hardware to run double byte code?
No.
It'll run on just regular hardware?
Yeah, IBM's documentation says you have to. It's a lie. It's basically just we don't want to deal with support calls from people who don't have an actual Japanese computer, I think.
Okay.
I mean, okay, you do want probably to have a Japanese keyboard, because the Japanese version of ASCII is slightly different. For one thing, it doesn't have a backslash. So, or rather, the backslash is not the normal character location. So,
Looks like a yen symbol.
yeah. So if I were to switch to code page 932,
you did it.
yeah, you can see the backslash is now a yen symbol, and if I want to say, well, CD OS2, I mean that will work because it translates directly between the yen and the backslash. But if I wanted to type an actual yen symbol, good luck. Because there's no key on the keyboard that would do that. And in presentation manager applications, I would probably have in my experience actually, I do have the opposite problem in that I can't type a backslash in a presentation manager application, which is running in code page 932, unless I actually have a Japanese keyboard. Which I do have one at home, but...
You can't use that alt with the digits trick? You know
that will only give you the ASCII value of the code that you enter. But the problem is, as I say, the ASCII character set in Japanese does not have a backslash in it.
Okay.
So alt that character code for backslash would again just give you a yen sign.
I see.
Again, it behaves slightly differently under presentation manager, but
The
it's
civilization
complicated.
without backslashes.
Anyway.
It works, sort of.
There we go. All right, we are actually getting a bit short of time, so there is a presentation after me, right?
Yep.
Okay.
There is one.
All right. So I'll try to be fairly quick through this one. This is something that I wrote for printer management. If you've used the ArcaOS, you probably have noticed that there is a printer management GUI in the printers folder, which is called PM Printer Manager. This is a program I wrote. It is actually open source. It's available on NetLabs. But to be able to have this program, which is written in REXX, it's written in VxREXX, I had to have the ability to properly manipulate printers and print queues and print drivers from REXX. And I just couldn't do it effectively without actually writing a REXX library that could do some of the lower level stuff that I couldn't otherwise. So RxPRT util, it's probably installed on all of your systems if you have ArcaOS. I would think it's in sysdll. So it basically lets you manipulate printers and print queues from REXX. So you can list installed printer drivers, you can list printer models that are supported by any printer driver, you can list all of the printer ports that exist on your system, you can query their configuration, you can get a list of actual defined print queues on your system, including some of their attributes. You can create and delete printers, and if you delete a printer using the library, it will properly delete it and the queue that drives it, which will not happen if you try to just delete the printer object from the workplace shell. There used to be an old trick using, I think it was a FaxWorks utility called prndrv, PRNDRV, that you would have to use to actually delete a printer, because otherwise it would delete the printer object, but it wouldn't delete the queue, and then stuff would get all out of sync. You delete a printer with this library, it will take care of that properly. You can open a workplace shell object of a printer, or you can open the properties dialog of a printer or a printer port. You can change or set the default printer. You can hold or release a printer queue. And yeah, basically all of the functions that my printer manager program needed, it does. So here's an example. It's slightly verbose, but oh, by the way, I probably should have touched on this previously. You might notice this syntax, RPU error, the other one had ULS error. So other than in RxLVM, which as I mentioned was my first library and I did things a little differently, most of my REXX libraries have the convention that when an error occurs in the function, it will return a non-zero error code and it will set a variable in the environment which contains an error message. So that variable name is going to be different for each library. For RxULS, it is called ULS error. For RxPRTutil, it is called RPU error. And every time a function is called, it starts by resetting this to a null string, and then when an error occurs, it will set it to that. And the error format is usually the name of the function followed by the return code from that function, where the function is, actually I might have that backwards, I'd have to look that up, but it returns both the function that triggered the error inside the API and the return code that it returned. So you can kind of tell what went wrong, and if you have access to the source code, which you do because this is open source, it's on NetLabs, you can actually see what line of the code it was failing on and maybe figure out what you did wrong, or what I did wrong. It's always possible. Amazing, I know, but. So yeah, basically this just dumps a list of printers and then opens the workplace shell object for the default printer on the system. So let me
Alex, Neil has a question.
Neil, how you doing?
Yeah. How many printer ports can OS2 have?
I'm not sure if there's a limit, really. There probably is. I would imagine it's at least 64, but don't quote me on that. Well, I mean, you can quote me on that, but don't hold me to it.
Okay.
All right, so I think I called it SPRT, right? unless I'm in the wrong directory. Okay, there. So, as you can see, it opened the workplace shell object, which is to say the printer queue of my default printer, which happens to be a PDF printer. But you can see what it did is it says 2 printers are defined, and one has the queue name PDF print and the human readable name PDF printer. The other has the queue name Brother H, and the descriptive name is Brother HL3075CW, which is the laser printer I have on my desk at home. Now, this is a very simple example. What I think I might want to do here is show you a slightly more sophisticated test script. So almost all of my REXX libraries on LentLabs include a script called test or testlib or something that runs through all of the functions and just demonstrates that they work. And I make sure to run this every time I do a build to make sure nothing's broken. This was sort of quick and dirty regression testing. But I will run this one, testlib, and I will pipe it. Actually, no, I will redirect it to a file. I'll call it dump.out. So it also opens the workplace shell object. But if I now look at dump.out, you can see all of the stuff that this script actually did. So it says it found the printer driver psprint.drb. It found that it supports 381 devices. And I could actually enumerate and list every single one of those if I wanted to. I just commented out the code that does it. Then it says it found 10 printer ports, and it lists them all. So the port name is at the start. Then the driver file of the port. So these are all DLLs, except they have the extension PDR. And that's the full path to the driver. And then the actual printer drivers themselves that are installed. As you can see, IBM null, that basically is always installed. And then the CUPS printer and my Brother laser printer driver. And then it actually goes through those printers and queries a bunch of information about them. So you can see these are my 2 actual printers. PDF printer, that's the name of the queue. It's got the flag D, which means it's the default printer. That's the actual workplace shell object handle of the printer object. The driver that it uses, which is IBM null, because it's basically just a dumb redirect. And then it sends to port CUPS1 because it uses the CUPS PDF printer driver. And then my Brother laser printer, which I currently have set to file for some reason, probably because I changed it to that on the road and never changed it back because I almost never print from this VM to that printer. But yeah, you can basically see all of this is kind of information that you can get out of this REXX script. There's other stuff that's in the test library that I sort of disabled, which is stuff like pausing and deleting a queue, or pausing and unholding a queue, and so on. So I don't know how useful this is likely to be to your average user, but if you ever need to like get deep into the printers on your system programmatically, that's an option. And it's there, and as I say, sources on NetLabs. And I have about 2 minutes left, so sorry, Matt, I might eat into your time a little.
No, that's okay.
So RxUtilX, RexUtil extensions. If we've ever used REXX, we know about RxUtil, which is the OS2 system API for REXX, which lets you do a bunch of kind of OS2 specific things from REXX. So going back to my first slide, remember how I often found myself saying, I wish I could do X. Well, this basically is a script, an API library that is designed to do a whole lot of X. So I call it sometimes stuff that should have been in RexUtil. So it's kind of a miscellaneous grab bag of useful functions at this point, but here's a kind of a brief summary of some of them. You can access the clipboard from a text process. Now this does not access the Unicode clipboard the way RxULS does, but it does let you do a couple of other things like delete all clipboard formats and stuff, I think. You can do some simple process management like query the current process or query the foreground process, which might not be the current process. Or you can get a list of processes. You can kill processes from here, in as much as you can successfully kill a process in OS2 at all, which sometimes is a bit questionable. You can get information like how much RAM is there about the system. You can replace locked files. You can do simple formatting of strings like time, number, currency. You can create and delete named pipes. I always thought this was an odd one because, you know, REXUtil since about Warp 4 FixPack 5 has had functions for using named pipes, but not for creating or deleting them. So they have to already exist for you to be able to use them. So I thought that was kind of a gap in functionality, so I added functions to let you actually create and delete named pipes, and then you can actually use the original REXUtil functions to do stuff with them.
How does that, as you create a handle or something and then it understands that, or?
Named pipes use names, so it's basically just a name that starts with, I think, /pipe or something.
Right, but when you reference it,
You use the
aren't you
name.
using a handle internally or not?
I don't
Are you
remember.
using
I
the
haven't,
name?
I haven't looked at that code in about 4 years, so yeah. And finally, large file access. So what do I mean by large files? Larger than 2 gigs. So, you know, the ability to read and write files, or just do anything with files larger than 2 gigs, is a relatively recent, by which I mean post-1998, addition to OS 2. And the standard REXX library, while it has great, very useful functions for opening files and reading and writing to them, none of them will work with files larger than 2 gigs. So I added a whole set of functions to do that. You can open a large file, close a large file, seek through a large file, write to, read from, basically the standard set. So I had, I think Steve Levine helped me test that one out a bit, so I'm reasonably confident that it works fairly well.
What did they do? Add some API calls
Yeah,
for large files?
you basically need to add like some special new flags to the DOS open command,
okay.
I think. Now, if you use GCC, GCC will actually handle that for you automatically because Bitwise put that in quite sensibly. But if you're using the direct native API, like DOS open, etc., yeah, I think you have to, I forget what the flag is, but you have to add something, and it's not set by default because, you know, backwards compatibility can't possibly change anything that might affect anything. So, and the idea of this was originally just like, I bet a bunch of people have things that they want to be in REXUtil that aren't. So I did kind of take some suggestions from people, and I'm still open to suggestions. And again, this is an open source project. It's on NetLabs. If anybody sees something that really should be in this library, I'm certainly welcome suggestions. Now, what I don't see this library as including is stuff that is better suited to a more specialized library, a good example of which would be, say, the LVM functions, or even the ULS functions. But these are functions of a general purpose nature, generally useful for just a whole wide variety of REXX scripts. Also, I don't necessarily feel I need to put in functions that are well covered by other third-party REXX libraries, unless said third-party REXX libraries are clearly abandonware, in which case I might want to put some of those things in. So Paul Ratcliffe has an excellent REXX library called PR1util, which I use in some of the programs that I'll be showing tomorrow. I see no reason to duplicate any of the functions in that because he maintains it, and I think the source of that might be available as well. So I don't feel the need to really duplicate work that other people have done unless, as I said, it's something that isn't maintained or there's no source code or something like that, in which case, yes, there might be an argument for putting things into REXUtil extensions. But in general, I like to think some people are finding this useful. I know, again, Steve Levine has said he uses it for a few things, which I consider a pretty strong endorsement.
You made a reference to clipboards. There are different types of clipboards.
Yes. So there's like the text clipboard and there's the bitmap clipboard and a few other things. Clipboard formats really. So whenever you write something to the clipboard, you specify the format, whether it's like CF text or CF bitmap or whatever. And there's others like the Unicode format, which not everything really knows about, but more things do these days than used to. Yeah.
Right, you can put it in there.
Yeah, you can. Just see if I
The
get.
trick is when you paste from the clipboard in an unexpected format to an application,
It
the
doesn't
application
know,
can crash.
doesn't know what to do with it.
Doesn't know what to do with the input.
All right, so quick examples of some stuff. Again, the usual boilerplate: register the functions, then query list of processes, query the system RAM. I also take the opportunity to demonstrate how to format a number nicely, and then query the screen resolution. So I'll show you this running, and I should probably pipe that. So what do we got here? A whole bunch of processes running. Yeah, you can hack my system now if you know what you're doing. Well, no, probably not. But I'm sure most of you recognize a lot of these. And then I've got 3.7 gigs of RAM, looks like. And then that's my screen resolution, which I had to say change to 1280 by 1024 in order to get this projector to play nice with it. So, and again, there's a whole bunch of other stuff this thing can do. I encourage you to check it out if you're interested. And again, like all of my REXX libraries, I do provide documentation, although I think in this case it's not a nicely formatted INF, it's just a text file. But yeah, these are the current functions that are in the library. So there's a fair collection in there. And I have not had occasion to add anything to it in a couple of years, but you know, I may still come back and add more stuff. I see it as an ongoing project. And again, I welcome suggestions.
And when you say it's on NetLabs, I forget this, that's like an FTP site or is it a website?
It's a website / Subversion repository, basically. NetLabs track. The URL's on the first site, but I mean, yeah, you can access it through SVN. So basically, they're all in SVN is really the upshot of it. So a very quick mention. This is kind of an honorable mention. It's a bit specialized, and I don't think it's going to be super useful to a lot of people. So VxREXX extras is an extension function I wrote for the VxREXX graphical REXX environment. And it basically just adds a bunch of stuff that was missing because Whatcom kind of stopped working on VxREXX around 1996 or 97 or so. So I added tooltip support because a nice GUI should have tooltips. I added a decent progress bar, a better button with better support for images and text combined on them, a Warp 4 style notebook control, which was something that a lot of us who had been using VxREXX before were really wanting for a long time, and then some useful functions to bring up different types of dialogues. So I have a function to bring up a color selection dialog, which actually uses the built-in Presentation Manager color wheel, and then a simple directory selection dialog, which I'm quite pleased with because it subclasses the file dialog, and which means if you have a file dialog enhancer which has been implemented properly, it will actually use that. And the I don't remember how well it works with the eco file open container, but it does work quite well with Xfile. And then again, clipboard functions, and these are basically the same that are in RxUtilX, except that I didn't really want to require the use of that, especially since this one can hook directly into graphical programs. So it was just convenient to add them as well. The source, as before, is available on NetLabs. This is the one exception. It is not under the RexLibs project. It is under the VX apps projects because it's VxREXX specific. And I kind of hesitated to put the source link on here because honestly, to almost everybody, it's not going to be useful because you need some fairly obscure tool chains to actually use the sources, none of which are actually available anymore. So you need the VxREXX Object Developers Toolkit. which was commercial software, which is now abandonware. Good luck finding a copy legally. There is. You also need very specific versions of the IBM C compiler and/or the Watcom compiler. It will only work with either, I think it's CSET++ 2.1 or Watcom 10.0C, I think.
Wow.
And I have kind of tried a few times to see if I could update it to work with newer compilers, and I've had no luck. Mainly because the VxREXX toolkit builds their libraries, builds it by linking to object files that it provides, and those object files are hard implemented to link to those specific C runtimes. I talked to Steve a couple of times. He seemed to think there might be a way to kind of persuade it to work with Open Watcom, but given how few people are even going to have the toolkit to be able to build these, I figure requiring CSET++ 2.1 on top of that doesn't really add much of a restriction anyway. So I can build stuff with it. Honestly, that's the main thing for me. If other people want to play with it, they are more than welcome to try. But, that's that. And I think that brings me to the end. I don't have a demo for this one because it's not really text. A text mode REXX library. Oh yes, one last note. Almost all of these libraries do use a common function framework, which is available as part of the REXLibs project. This is basically a set of functions that they all use for allocating memory for REXX strings, which is what they use to handle the input values, the return values, do some of the error handling. It has pre-built functions for creating stem variables, both array type and what you might call hash table type or dictionary type. Some of the standardized error code handling is also in there. Basically, this is kind of a framework that I can use to get a quick start on building a REXX library. It was mostly written by me. Steve did some improvements, mainly in areas where I hadn't entirely understood what the IBM documentation was failing to say properly. But yeah, and anyway, any other person can also use it. It's all open source, it's all on NetLabs, and yeah.
So if you go to track.netlabs.org, is there some kind of index page that comes up so
Yeah.
you can find stuff?
Yeah.
Okay.
So I think that's it for real this time. Yes. Any questions? Yeah.
These are all available today, are they?
Oh yes.
Because it's stuff I've been looking for a long time and didn't know they existed, so.
Yeah, that's why I decided to do the presentation. It occurred to me that a lot of people probably didn't know they existed. They were almost all written years ago. RxLVM, I think I wrote again back in almost 20 years ago. RX, probably the newest one is the print utilities one, which I wrote maybe 5 years ago. And I have updated a couple of them periodically since. In fact, I just committed an update to RxULS to improve some of the error handling that I ran into when I was writing my example scripts here. It was not a problem in the library exactly. It was a problem with me screwing up some of the inputs to a function, but I figured it could have done a better job of handling those inputs and reporting what the real error was. So I committed a slight change. I haven't done a release build of that change yet, but that will come. So yeah, thanks. I'm glad to know you might find these useful. Anyone else? Anything online?
No, no.
All right. In that case, Matt, I think it's yours.